I'm going to go ahead and get started here with homework number 3. And the name of this is greater value. And in this homework assignment, we're going to be talking about inequalities as well as absolute value. So the first problem, number 1, it says, write the inequality that represents the sentence. And the 4 basic inequalities are all ones that I'm sure you've seen before, are less than, greater than, less than or equal to, and greater than or equal to. So we're going to be working with these 4 inequalities. Remember, we've worked with so far, we've worked with expressions and equations. We've discussed their differences. And now we're going to introduce inequalities. All right, so these are the 4 basic inequalities over here, and we're going to work with each of them. So the first question, it says, write the inequality that represents the sentence. So number 1 says the sum of a number, so it's going to be a variable. We're going to create a variable to represent that number. So the sum of a number, I'm going to use x, and 5. So sum is addition. So the sum of a number and 5 is less than -7. My daughter is in 2nd grade right now, and they're going through inequalities, greater than, less than. And the way that they teach them is that the mouth right here in the inequality opens up to what they want to eat. And if there's more M&Ms, they would rather eat the more M&Ms than the less M&Ms. So whenever you see this, know that the mouth will always open up towards whichever one is greater in the end. But reading from left to right, if you see this, this is the less than symbol. So I'll go ahead here and, so I'll go ahead and up here and say this is less than, this is greater than, I'm just use a G because I'm not going to fit in there. And this one right here is less than or equal to. And this one right here is greater than. Greater than or, I don't know why that keeps, or equal to. Yeah, there's like random lines that keep shooting out there. That's not good. All right, so greater than or equal to. So in this case, this reads x plus 5 is less than -7. Okay, so that would be my answer for number 1. Number 2 says the product. So product is multiplication. So I know I'm dealing with multiplication. Whenever you hear multiplied by or the product of, you know you're going to deal with multiplication. So the product of a number and 8. So we're dealing with 8 and a number. So 8 times whatever that number is. I'll use x to represent that. The product of 8 and a number and 8 is at least 25. So we know we're dealing with 25, but what does at least mean? And think of it in terms of you have to be at least this age to do something. So there are certain things that you have to be a certain age in order to do. So for example, when you're going to rent a car, even though you can get your license a lot earlier, in order to rent a car, a lot of places require you to be at least 25 in order to rent a car. So at least 25. And you think about it, well, if you're 25, could you rent a car? And the answer would be yes. So it would include 25. So you're not saying that it would be less than or greater than. You know that you could actually be that age, so you would use one of the equal to symbols as well. So Once again, the product of a number and 8 is at least 25. So you know that it's going to be at least the lowest possible number it could be is 25. And everything other than that, the mouth would open up to in this example right here and say it would be more than. So anything at least. Another example maybe you could add to that if you're still kind of struggling with that concept. Like I said, the 25 example, you have to be at least 25 in order to rent a car. Okay, so that means, okay, let's try this. If you're 16, is 16 greater than or equal to 25? The answer is no, it's not. Okay, if you add like 32, is 32 at least 25? Yeah, it's at least 25. Is 25 at least 25? And the answer is yes to both of these. So whenever you hear at least, you know that it could be equal to that number and still be okay, like in this example, because 25 is equal to 25. So in this case, you would use the greater than or equal to symbol. Every time you hear at least, you're going to use that greater than or equal to symbol. Just a heads up. Okay? Number 3. Number 3 says negative 24 is greater than or equal to 12x. Okay? So we're going to go ahead and solve this. So the question says to solve the inequality and then graph the solution. So it's a 2-step problem. You cannot just solve it. You have to also graph it. And I'll show you how to graph it afterwards. So the first thing is to solve it. And what you want to do is just like any other equation, like imagine that it would say like negative 24 is equal to 12x. You would just solve it just like you would with this equation, right? So like if this were the equation that you were starting with, I'll go ahead and move this over here. If you were to say like negative 24 is less than, negative 24 is equal to 12x. Let's just say this was the problem right here. Let's just say this was the new problem. If I were to divide each side by 12, I would get negative 2 is equal to x, which is the same thing as saying x is equal to negative 2. So we're going to solve number 3 just like we would solve this type of problem with one exception, okay? And I'll show you at the end. So if I divide each side by 12, this looks very similar to the problem I just did. I get negative 2 and I get x. And now you're just going to bring down this symbol, whatever it is. Okay. Now, if I were to divide by a negative number, if this, let's say I have a problem, I'm going to go down here in the bottom right corner and say, if the problem looked like this, negative 24 is less than or is greater than or equal to negative 12x. If I am ever dividing by a negative number, you see how this is a negative number right here? If I'm ever dividing by a negative number, I have to flip the sign. I have to flip this sign right here in the answer. So what I would do is I would just flip it in the opposite direction. Okay, and say something like this. I'd say, right, I'd make sure to flip the sign the opposite way. And then I always want to get x on the left side of the equation. So, normally you just be able to flip it. But if I do flip it, I also have to flip the sign here, because if you look in this inequality up here, if you look at it, the arrow is pointing towards the x. So I also have to have that arrow pointing towards the x in the answer. So if I ever flip it in the end just to write the x in the front or the variable in the front, you have to also flip the sign. Okay? So whenever you divide by a negative number, flip the sign. And I can't stress that enough. because there will be many problems that require you to do this. Okay, so if you're like skimming through this, make sure that you understand that concept. Okay, so the answer in this case would be x is less than or equal to -2. Now remember, this is only the first part of the problem. Okay, the second part of the problem says to graph the solution. So what I'm going to do is I'm going to draw a number line. You're going to graph this on a number line. All right, so when you are graphing an inequality, you want to first see what the answer is. So it's -2. I'm just going to go ahead and start at like -4, -3, -2, -1, 0, 1, 2. And you can go up to as high as you want. It doesn't matter. Okay, so when I graph this, if I'm using, and I'll go all the way back up to the top here. If I'm using a less than symbol or a greater than symbol, my dot that I'm going to use is going to be an open circle. Okay, you're going to use an open circle to graph it. But if you have one of these on the right side over here, okay, so one of these, I'll go ahead and make this a little bigger here. If you're using one of these inequalities, less than or equal to or greater than or equal to, you're going to use a closed dot or a closed circle when graphing it. So in this case right here, I would find the number, going back to our answer, x is less than or equal to -2. I would find -2. I see that it's less than or equal to. So including that, I'm going to have a closed dot because it's less than or equal to has a closed dot. Then I'm not done. I have to then point to whichever way the arrow is facing. So all the values that are less than or equal to -2. Okay, so all the less than to the left. These are all less than the value. Meaning that if I look at this graph and look at this picture, I know that all the possible values that could work are all graphed. Remember that this arrow at the end on the left and on the right means that it goes on forever, an infinite number, okay? So -20 would work. -9 would work, -4, -3, -2 would work, and all the possible values that would make this true. Okay, so moving to the next problem. Okay, so now we're going to move on to number 4. Okay, and it says the same thing, solve each inequality, graph the solution. So it's a 2-step problem once again. So I'm going to say 2 times the quantity of m minus 3 plus 7 is less than 21. Okay, so just like we would with a normal equation, we're going to work through this. Okay, so first I want to use the distributive property and multiply each. So 2 times m is 2m. 2 times -3 is -6. Bring down my adding 7 is less than 21. Okay? And then I'm going to go ahead and combine these two terms. So I'm going to say 2m plus 1, because -6 plus 7 is 1, is less than 21. Then I'm going to subtract 1 from each side. Okay, and I get 2m is less than 20. And then I divide each side by 2, and I get m is less than 10. Now I can keep that. I don't have to switch the sign or anything like that. I know that I'm able to leave that as is. I'm not dividing by a negative number. This value right here, 2, is a positive number, so I don't have to worry about flipping this sign. All right. So now, the second part of it is to graph it, right? So let me draw my number line. And I'm just going to put 10 in the middle of this number line. That's normally how I like to start. And then I'll include a couple of values before and then also include a couple of values afterwards. Oops. And it's important to do this because it's a good visual aid in order to help in the future, and I'll explain more about it later. But if you remember from the last example, the less than or greater than signs, this sign right here, you have to use an open circle when graphing it. So I'm going to go ahead and use my open circle, and all the values that are less than, m, which are all the values less than 10. So show me all the values that are less than 10. All of these values on infinitely to negative infinity are all less than 10. Okay? And notice that the open dot, the reason why you would include that open dot is because if you were to put 10 in for m and say, is 10 less than 10? No, 10 is equal to 10, so that would not work, right? So you couldn't include that in there. So you have the open circle saying like, hey, look, 9.8 could work, 9.2 could work, any number less than 10. And this visual right here, this graph, allows you to look at it and find all the values. I'm a very visual person, and that definitely helps me. All right, number 5. Number 5 says solve each problem by writing an inequality. All right, so I'm going to write an inequality. The length of a picture frame is 3 inches. So I know I'm dealing with a picture frame, so I'm just going to imagine that I have a picture frame. I don't know why it keeps doing that. The length of a picture frame is 3 inches greater than the width. So, like I said, I'm a very visual person, so I'm drawing it. So this is the width, right? The length of the picture frame is 3 inches more. Okay, so I know this side is a W, and this side is W plus 3. Because whatever the width is, you're going to add 3 to it to get the length. And it says the perimeter of what it takes to go, basically is to start from here and to go all the way around, whatever that measurement is, the perimeter is going to be less than 52 inches. So what I could do here is, I could do something like this. I could say, all right, so 2 times the width, right? Because I have a W here and a W here. I could say 2 times the width plus 2 times W plus 3, which is right here. We have 2 of them. Okay, is less than 52 inches, is less than 52. All right, and if I wanted to write this out, right, maybe combine as we go, I could write it as use the distributive property here. 2 times W gives me 2W. 2 times 3 is 6. And I'll bring over this 2W plus 2W plus 2W is 4W. Plus 6 is less than 52. If I subtract 6 from each side, I get 4W. 4W is less than 46. Okay. And then what I need to do here, I'll rewrite it over here. I'll say 4W is less than 46. And I'll divide each side by 4. And just say W is less than, and then you would go through and divide that. So 46 divided by 4. So we'll go ahead and go the long way. So I get 1, okay, subtract, and I bring down the 6, and I have 1 that goes in there, subtract 4, so 11 point, and I bring down a 0 to borrow, 11.5. You could put that in a calculator, but, I just did the math there. So 46 divided by 4 gives you 11.5. So the width is less than 11.5 inches. Okay. I'll go ahead and just leave that there. Why not? All right. Moving on to the next one. Let's go to number 6. 6. It says the cost of a field trip is $220. $220 plus $7 per student. Plus $7 per student. Okay, so altogether, you're gonna pay $220 for, like, say the teacher wants to go. Let's say I want to take you guys to the the U.S. Treasury, right? And we go there, and they say, oh, it costs $220, and then it's gonna cost an additional $7 per student that you bring. So I try to do the math and figure out what it's gonna be. Let's say I go to the principal, and they say, hey, you know what? You can only spend $500. Okay, if the school can only spend $500, let's say I'm paying for all of you guys, we know that it cannot go over $500, but it can include $500. So the question is, how many students can go on the field trip in the end? So we know that if it can include, it needs to be, whoa, keep on doing this. It needs to be less than or equal to $500. So the price cannot go over $500. So the question is, how many students can go on the trip? Let's figure this out. So I'm going to get rid of that $sign there. All right. Just write it like this, where S represents the students. All right. So the first thing I'm going to do is I'm going to subtract 220 from each side. And then I'm going to get 7S. I don't know why that keeps doing that. I'm going to have to look into that. 7S is less than or equal to, I'm going to go ahead and subtract. 500 minus 220 gives you 280. Okay, 280. And then I'm going to divide each side by 7. And I get S is less than or equal to, and 280 divided by 7 and gives you 40. Okay? So I know that if S is less than or equal to 40, I can bring at most 40 students. Right? So how many students can go on the field trip? I'll just say the answer would be no more than 40 students. Right? So I could bring 20 students, I could bring 38 students, 39, but it gets to a point where anything over 40, I can include 40 students. 40 students could go, and we'd hit exactly the $500 mark. But if I have anything over 40, then that would be over budget. Okay, that would be the answer, number 6. Number 7, is the inequality always or never true? These problems always true or never true? Really just, is this inequality true or false? That's what it's asking. So check this out. I have 9 times the quantity of x plus 2 is greater than 9 times the quantity of x minus 3. So look at this problem. First, the thing that I'm looking at is, look, there's a multiply by 9 on each side. And I could go through and run the distributed property and do all that, but I'm going to work smarter, not harder in this case, and say, all right, really there's a 9 on each side that's being multiplied. I'm just going to cancel them out. I'm just going to cancel them out because I could just divide each side by 9, right? If I say, all right, I'm just going to divide, whatever I do to one side, I could do the other side. And what that does is that would go ahead and divide, that would divide out that 9 there. So here's what I end up doing. I could do this. I could say, well, let's see. Yeah, I'll do that. And that would cancel the 9s out. And that leaves me x plus 2 is greater than x minus 3. Now I have an x on each side, and I could just subtract x from each side, right? and that would leave me 2 is greater than negative 3. Is 2 greater than negative 3? True or false? And the answer is true. So in this case, I would say the answer is always true. Okay, so I went ahead and just wanted to see what it would come out to. And in this one, it was pretty quick in answering it, but at the same time, if you got confused, I'll walk back through. I divided each by 9 in the beginning, and I subtracted each by x in order to get that answer. All right, so I'm going to go ahead here and add another screen so I can answer the next problem. The next one is number 8. We are over halfway done. And have negative 7 times the quantity of 3x minus 7 plus 21x is greater than or equal to 50. Okay, so I'm looking at this, and the first thing that I want to do is use the distributive property here. And negative 7 times 3x gives me negative 21x. Negative 7 times negative 7 gives me a positive 49. Okay, and then I'm going to go ahead and add 21x here. Now, what I'm looking at, I see negative 21x plus 21x. Well, that just cancels each other out. So negative 21 plus 21 is 0, so that just cancels it out. And that leaves me with 49 is greater than or equal to 50. Is 49 greater than or equal to 50? No, 49 will never be greater than or equal to 50. So the answer is never true. Number 9. Okay, it says solve each compound inequality. And then it says graph the solution. So it's a 2-step problem. So solve and then graph. But now these are including and or. And I'll show you what to do with each of them. So really there's 2 that you're solving. You're solving 2x is greater than negative 10. And you're solving 9x is less than 18. So really, someone's giving you 2 conditions, saying, hey, look, it's got to be this, and it also has to do this. These are the 2 possible solutions. And if you go through and solve the first one, you would divide each side by 2, and you get x is greater than negative 5, and divide each side by 9. Say x is less. That's so weird. I don't know why it's doing that. X is less than 2. Okay, so now you're not done yet because you haven't even finished the first step yet. So now we're looking at this and we're saying, all right, so this is an and. How can I combine these together? In an and, I want to combine them. So I could do something like this actually. And watch this, and I'll explain it why I did it after the fact. All right? I wrote something that looked like this. Because this part right here, x is greater than negative 5. Couldn't I also write that as negative 5 is less than x? Right? Because the mouth opens up towards the x in both of them. So in writing that, you think about it, negative 5, I'll write this over to the right. Negative 5 is less than x. And then you just keep this part of the problem, x is less than 2, and just add that onto the end there. Okay, so the answer in this case would be negative 5 is less than x. Sorry, negative 5 is less than x, which is less than 2. So I know x has to be between negative 5 and 2, and that would be my answer. So anything, if you go back and try, all right, so a number that falls in between negative 5 and 2, well, 0 falls between it, right? So if I go through and Well, I'll use 1. I'll use 1 as an example. 1 works as well. But if I try putting this into the original problem, right? If I try putting 1 into it, 2 times 1 is 2. Is 2 greater than negative 10? Yes. And then I try over here, 1 times 9 is 9. Is 9 less than 18? Yes. So it has to satisfy both of these conditions. That's why there's the and there. So both of those logical operators. And if you guys ever take computer science or programming, there's a big difference between and or. But you know in this case that when you solve the problem, that when you get 2 answers and it says and, you can combine them together into 1. Okay? And you always want to have the arrows facing you always want the arrows facing that way when writing it. Just because this makes sense logically from left to right, where -5, the lowest number, is going to be on the left, the variable is going to be in the middle, and the biggest number is going to be on the right. Okay? So make sure when you write it, that also makes it easier to actually graph. So if I'm writing these numbers right, I'll just start here. I'll start at -6, -5, -4, -3, -2, -1, 0, 1, 2, and 3, right? I just pick numbers. But now if I go through here, I say -5, all right, is less than x, okay? So I'm going to go ahead and include an open circle, and then go to my 2. Since that is less than as well, I'm going to go ahead and include an open circle. Now all the values that are greater than -5, and it keeps going up, greater than, all these values would work until it would stop right at the 2. So all of these values would actually work and would make the 2 inequalities at the top true. Okay, so I have -5. -5 actually would not work. That's why I have the open circle there. But -4 would work, -3, -2, -1, 0, 1, all the way up to 2, but not included. So if I ever ask you to graph, this is what I want to see. Okay? So it's a two-step problem. The first thing we did was we actually found the answer, and the second thing we did was we graphed it. Okay? Moving on to the next one. Let's go ahead and move to number 10. It says 8x is greater than -32, or, not an and, or -6x is greater than or equal to 48. Okay, so once again, I'm going to solve each. I'm going to divide each side by 8. I'm going to bring down this side and say -4. Or divide each side by -6. Remember that when you divide by a negative, you must flip the sign. So I'm going to have to flip this sign right here to make it face the other way whenever I divide by a negative number. Okay? Whenever you divide by a negative number. So that gives me -8. All right? And whenever you're dealing with an or, you don't have to go past here. You're kind of good. Okay? So I know that x can be greater than -4, or x is less than or equal to -8. And I'll show you why. Check this out. So that's the first part of the problem. Then I have to graph it. All right? So I'll start at -9, -8, -7, -6, -5, -4, -3, -2, -1. Make sure that your bigger number is always on the right, your smaller number is on the left. All right, so x is greater than -4. So I find -4, and I'm going to put an open circle, and all the values that are greater than, so greater than, all the ones that are this way. These are all the values that are more than. Okay? And then, or x is less than or equal to -8. So this is going to be a closed circle, right? Because it can include -8 and all the values that are less than. So it's going to go this way to the left. And then I'm going to go ahead and include the arrow as well. Make sure to always color in the arrow and make sure it's facing the right way. Okay? And this would be the graph that works too. Okay, so that's how you would solve number 10. Okay, moving on to the second part of this homework, we're moving to absolute value. Now, the absolute value of a number is how far it is from 0 on a number line. So, for example, if I have 0 on my number line, and I have -1, -2, -3, right? Let's say on this side I just have 1, 2, and 3. Make my number line. If I want to find out what the absolute value of 3 is, I just count upwards from 0, counting up to 0. So I start 3, and I start at 0, 1, 2, 3. So really the absolute value, and you write the absolute value by writing those long lines in programming, they're called pipes, right? But the absolute value of 3 is 3. If I was looking at -2, let's say I wanted to find the absolute value of -2. The absolute value of -2 would be 1, 2. So the absolute value of -2 would be 2. So the answer will always be a positive number whenever finding the absolute value of something. Okay, so let's go through and let's take a look at number 11. And it says, solve each equation. But now, you have the absolute value of 3x equals 18. You might think, how do I find the absolute value of that? Well, what you would do is, you would break this down into 2 separate problems. Check this out. So the first thing you would do is, you would take 3x equals 18, okay? And then you would also write 3x is equal to -18. You would write the positive version of the answer as well as the negative version of the answer. And that might be confusing, but that's just the procedure of what you would do here, okay? So whenever you see the absolute value is equal to a number, you just need to break it down 2 ways. You need to have the positive version of the answer as well as the negative version of the answer. So let's go ahead and let's solve each. I'll start with this one. I'll say x is equal to 6. Okay, and then I'll solve this one. And I'll say x is equal to -6. So either one of these could solve this inequality. And here's why. Let me just check my work. The absolute value of 3 times 6 is equal to 18. That would give me 18. The absolute value of 18 is equal to 18. Right? Is 18 equal to 18? Yes, it is. And if I do the other version of it, right? If I say the absolute value of 3 times -6, I'm just checking my work here, is equal to 18. I get the absolute value of -18. How far is -18 away from 0? Well, it's 18 places. Is 18 equal to 18? Yes. So in this case, you're going to have 2 answers. Okay, those would both work. X equals 6 and x equals -6. So both of those answers would work. So let me just break this down again. Whenever you get a problem that looks like this, right, and you have you have a absolute value, okay, and you have this expression inside, 3x equals 18, I would just break it into 2 separate parts, right? I would just say, all right, I'm going to add the positive 3x is equal to 18 and 3x equal to -18. And then solve it. And both of those could actually work to solve it. Okay, moving on to the next one. Number 12. A couple more. Number 12 says, the absolute value of x minus 3 is equal to 9. Okay, so once again, I'm going to break this into two separate equations. I'm going to say x minus 3 is equal to 9, and x minus 3 is equal to negative 9. Okay, so I'm going to go ahead and add 3 on each side. I'll focus on this one first, and I get x is equal to 12. Whoa. X is equal to 12. And then I'm going to add 3 on each side over here. Negative 9 plus 3 is equal to negative 6. So both of these would work. I'm just going to circle them. So x equals 12, x equals negative 6. And if I were to check it and try substituting in 12 for x up here, 12 minus 3 is 9. And the absolute value of 9 is 9. If I try substituting in negative 6 for x, negative 6 minus 3 is negative 9. The absolute value of negative 9 is 9. So both of those would actually work. You can always check your work. All right, 13. The absolute value of x plus 4 plus 3 is equal to 17. All right, so this will require one step before we split the equation up. Because if you remember in this one right here, number 12, we didn't have anything added on to the end here like that. So we're gonna have to make our inequality, make our equation, not inequality, we're gonna make our absolute value equation look like that. All right, so the first thing I'm gonna do is I'm gonna subtract this 3 just to get it out, because I'm like, hey, I don't want that over there. So that leaves me with 14. And I bring everything else down. X plus 4, the absolute value of x plus 4 is equal to 14. So now I can go ahead and break it up into two ways, because now this looks a lot like that, right? I don't have anything after, I don't have any terms after the absolute value. I can focus solely on this. So I break it two ways. I could say x plus 4 is equal to positive 14, and then you say x plus 4 is equal to negative 14. All right, let's solve both. I'll subtract 4 from each side, and I get x is equal to 10. And then over here, I'm going to subtract 4 from each side, and I get x is equal to negative 14 minus 4 gives me negative 18. Okay? And that's my answer. Moving on. Last few. All right. 14. It says solve each equation. Check for extraneous solutions. So we'll show you what that is. All right. So 2y minus 4 is equal to 12. All right. So let's go ahead and take a look at this. If I were to split this up two ways, I could say 2y minus 4 is equal to 12. I could also say 2y minus 4 is equal to negative 12. I'm going to start with this one over here, and I'm going to solve it. I'm going to add 4 to each side, and that gives me 2y is equal to 16. Divide each side by 2, and I get y is equal to 8. I'm going to go ahead and add 4 to each side here, and say 2y is equal to negative 8. Divide each side by 2, and I get y is equal to negative 4. Okay, so these are my two possible solutions. Now, sometimes when you go back and check your work, some of these values don't actually work, and that's called an extraneous solution, which means that we're not going to include it. Because if it doesn't work, we solve it, and it doesn't work, then that's a problem. So we're going to check and make sure they work. So 2 times 8 minus 4 equals 12. I'm going to put that, I'm just going to substitute that in for the original problem. And let's go ahead and solve this. The way I would do that is say 2 times 8, which is 16. 16 minus 4 is 12. The absolute value of 12 is 12. So that one is right. Okay, so we know y is equal to 8. Now let's try the other one. All right, so we'll say 2 times negative 4 minus 4 equals 12. So we multiply 2 times negative 4. That gives me negative 8. Okay, negative 8 minus 4 equals 12. And then negative 8 minus 4 really gives me negative 12. The absolute value of negative 12 is 12. So it's true. So these both work. Okay, so in checking for extraneous solutions, we did not have any extraneous solutions. And like I said, an extraneous solution is if we get down to the very end and we realize, wait, 13 is equal to 12. That's not right. So we're just going to check and make sure. It's always good to check our work and not just assume that it's right. Number 15. 2x plus 5, the absolute value of 2x plus 5 is equal to 3 times x plus 4. All right, so now check this out. We're going to solve this, but we're going to break this down 2 separate ways. The first way, I'll write it as 2x plus 5 is equal to, remember I have to have a negative answer on the right side, right? So what I have to do is I have to take all of this and multiply it by negative 1 in order to make it a negative answer. Okay, so that's going to be my first side. And the other one, well, I'll do it the way that I was doing it before, where the first side on the left, I just wrote it as is, right? And then on the right side, I'll go ahead and rewrite what I just had, right? 2x plus 5. And then you have to multiply it by a negative, right? Because you want that side to be a negative number. So I could just say like negative times 3x plus 4. So negative 1. Now, let's solve the one on the left. Okay, so I get 2x plus 5 is equal to 3x plus 4. I'm going to go ahead and subtract this 2x from each side. Okay, and that gives me 5 is equal to x plus 4. And then I'm going to go ahead and subtract 4 from each side. Okay, and that gives me a 1 is equal to x is equal to 1. All right, now I'm going to do the other problem. The first thing I'm going to do is I'm going to bring down the left side of the equation. And I'm going to use a distributive property, distribute that negative 1 to everything. So I'll say negative 3x minus 4. All right, so I'm going to add 3x to the left side. I'll really add to both sides. And that leaves me with 5x plus 5 is equal to negative 4. And then I'm going to subtract 5 from each side. Okay, and I get 5x is equal to negative 9. Okay, so now that I've gotten here, I want to go ahead and divide each side by 5. And I get x is equal to negative 9 over 5. So if I were to leave this here, I could just assume, all right, that's a fraction, negative 9 over 5. And I'll go ahead and divide that out. Negative 9 divided by 5 gives me negative 1.8. All right, so I could just say x equal to negative 1.8. You could write it like that too. So if I go ahead and check my work, let's go ahead and check for x equals 1. I could say the absolute value of 2 times 1 plus 5 is equal to 3 times 1 plus 4. All right, so let's go ahead and work through this. 2, absolute value of 2 plus 5 is absolute value of 7. I'm bringing all this down, saying 3 times 1 plus 4. 3 times 1 is 3, plus 4 is 7. What's the absolute value of 7? Gives me 7. Is 7 equal to 7? Yes, it is. So I know that this answer is correct. So let's check negative 1.8. Okay, so I have the absolute value of 2 times negative 1.8 plus 5 is equal to 3 times negative 1.8 plus 4. All right, so negative 2 times negative 1.8 gives me negative 3.6 plus 5 is equal to, and I'll bring all that down later, I'm going to solve the left side here, negative 3.6 plus 5 gives me a positive 1.4. If you were to take negative 3.6 and add 5 to it, you get a positive 1.4. So that equals 3 times negative 1.8. And I'm just going to multiply real quick. 3 times negative 1.8. That gives me negative 5.4 plus 4. So this gives me 1.4. And then if I add on this side, negative 5.4 plus 4, that gives me a negative 1.4. Is 1.4 equal to negative 1.4? It is not. Okay, so this would be something called an extraneous solution, right? So the way I would write this out, I would say x equals 1. So in the very end here, all the way down here at the bottom, I'm going to say x equals 1, and then I'll say x equals negative 1.8 is an extraneous solution. All right, so I went back and checked, even though I got that as the answer, I went back and checked and realized, hey, that doesn't actually work here. And like I said, that's called an extraneous solution, where you solve it, and then you go to substitute it back in, and you're like, hey, it's not necessarily working. So it's assuming, in this case, that 1.4 is equal to negative 1.4, which is not true. It's not true. Okay, so those were the 15 problems for homework. This last problem right here is a little bit more difficult, took some time to work through, and we'll get further into extraneous solutions next week, actually. This was just an intro to absolute value, the last tail end of this lesson. So next week we'll expand a little bit more. We'll talk about extraneous solutions a little bit more before our first test. And if you have any questions, let me know.